Here we go again, guys. Unit 2.3, transformation of function. How do I describe a translation on a function? So, really quick, let's review some function notation. We talked about this in last unit. Remember this. How do we read this? F of x. This will be g of x, h of x, and so forth. So similar to what you've seen in geometry last year is a translation function. So it's t, at the bottom it's a, b. So it looks something like t, a, comma, b. So to make a little cheat note, we're going to do this. So a represents the how much a function goes left or right. So a means left or right, and b, whether the graph go up or down. So how do we know where it goes? So if a is positive, then the function goes to the left. If a is negative, the function goes to the right. Now for b, if b is positive, it means it goes up. If b is negative, it goes down. Another way we could represent translation of a function is just by adding numbers to x or to the actual function. So if f of x is a function, f of x plus a is a translation to the left or the right. So here, if a is positive, it goes left. If a is negative, it goes right. And then the last way that you're going to see on the regions is f of x plus b is a translation up or down. So notice this b is being added to whatever my f of x function is. If b is positive, it goes up. If b is negative, it goes down. So these are a few examples of how a transformation of a function look like. You can have f of x plus 1, you can have g of x minus 2, or you can even multiply the entire function. In example 1, given f of x is equal to x squared, find f of x plus 1. So all this means, you see the plus 1, I am adding 1 to the input. So then I would rewrite this as f of x plus 1. Here now, remember substitution for last unit? We're going to substitute everywhere I see x in my f of x function. I am going to replace it with x plus 1. So I will get this as my final answer. Remember the function was x squared, so I'm replacing x with x plus 1. I can work this out or I can leave it like that. It doesn't matter. That example 2 says, given g of x is equal to x plus 4 squared, find g of x minus 2. So this minus 2. The minus 2 means we're subtracting 2 from the final output. So whatever this is, we're subtracting 2. So g of x minus 2 is actually my g of x function, which is right up here, x plus 4 squared minus 2. And then we would simplify this. That's it. Now let's see how this works. So it says sketch the graph f of x is equal to x squared. And then you want to sketch the graph f parentheses x minus 3 plus 2. And then the last thing, I want to write an equation in both standard and vertex. So you're going to go to your calculator and you're going to sketch this. F of x equals x squared. That's a piece of cake. Now I want to do f of x is equal to x minus 3 plus 2. So before I even sketch that, let's try to do the equation. So f of x minus 3 plus 2, I'm using my function f of x. Wherever I see x, I'm going to replace it with x minus 3. So this becomes x minus 3 squared plus 2. That's my new function. Okay, all I did was replace the x up here. Notice it was x squared. I replace it with x plus 3 and then I added 2. So when you graph this new function, you should have something that two graphs that look like this. The red is my x squared. Now let's not write that. The red graph, as you can see here, is by x squared, and the blue graph is x minus 3 squared plus 2. So if you look at this, this is in vertex form. We're going to simplify to standard form. But you got to be careful. We said, look at what this is asking me. Plus 2 means that the graph went 2 units up. Up 2. And then we have minus 3. Minus 3 saying that the graph went right 3. So this is my starting. I went 1, 2, 3, and then I went 2 up, and that's where my new point is. So let's just do that again so you can see what it means. This is where I started. It says I go to the right 3 and then up 2. So I go 1, 2, 3. That's 3 right, 1, 2, and that's where my new vertex is. Now, how do we write this in standard form? So my vertex form is right here. I need to make this into standard form. So what am I going to do? So standard form, let's just write here so you don't get confused. Standard form for a quadratic, remember we talked about that already. Y is equal to ax squared plus bx plus c. So I want to take this and make it into standard form, x minus 3 squared plus 2. I like to use the box method on the side because I have to square everything in parentheses. This becomes x minus 3, and let's fill in this box. So x times x is x squared minus 3x. X times negative 3 is minus 3x. Negative 3 times negative 3 is a positive 9. These are my like terms. So x minus 3 squared is actually x squared minus 9x plus 9. And don't forget the plus 2 at the end. So our last and final step is just combining like terms. Notice these are like terms. So my standard form would actually be x squared minus 9x plus 11. And this is my equation in standard form. Here is vertex form. Okay, the question asks for both. Write a final equation for the transformation in both standard and vertex form. So what you're going to work on is Portfolio 2.3. Remember, do your checklist for this week as you finish the lesson, so you keep on track. Am I on task? Am I doing what I'm supposed to do? Questions? Check in with Miss Ewing or myself. Alrighty guys, see ya!